Okay, now we're going to take a look at problem 3 on week 2 assignment and try to create a spreadsheet for this problem so that we can easily solve this problem if our data changes. So, okay, in problem 3, Farmer Frank operates a swine confinement operation with a 2,500 head finishing building. This building produces 1.1 million gallons of swine manure per year. The nutrient content of this manure is determined to be 45 pounds of nitrogen per 1,000 gallons of manure. Farmer Frank fertilizes his corn ground at 1.1 pounds of N per bushel of corn predicted. He predicts a yield of 180 bushels per acre. Well, the first question is pretty easy here. How many gallons of manure does he need per acre? Well, first of all, we need to know how many pounds of N. And as it says in the problem, he fertilizes at 1.1 pounds of N per bushel of corn predicted. Well, he predicts 180 bushels of corn, multiplies that by 1.1 pounds per bushel, gives us a total requirement of 198 pounds of N. So what I do in this particular problem is just simply take 198 pounds of N is to, we don't know how many gallons of manure, but we know that 45 pounds of N is to 1,000 gallons of manure. So when we solve for X in this problem, we find that the answer is 4,400 gallons of manure. So then to figure out how many acres can we fertilize with this building, 1.1 million gallons divided by 4,400 gallons per 1 acre equals 250 acres. So let's go ahead and solve this problem. Remember, we establish the spreadsheet by telling what do we know. What we know is pounds of N per bushel produced. I wrapped text there and then I centered it. So as I said in the problem, I need 1.1 pounds of N per bushel produced. I want to produce 180 bushels. So the answer is 1.1 pounds of N per 180 bushels equals 198 pounds of N required. So I need 198 pounds of N. Okay, and the manure, the nitrogen content of manure, that's given to us. And I'm just going to call this per 1,000 gallon. It was 45 pounds of N per 1,000 gallons. Now let's go back to the problem. So first of all, I want to figure out how many gallons of manure per acre I need. Let's go back to the problem here. I set up a proportion here, and we solve this thing algebraically. We cross multiply. 198 times 1,000 gallons is 198,000 gallons. Then we divide, or equals 45x. We then divide 198,000 divide by 45 equals x. X equals 4,400 gallons. Okay, so we take pounds of N times 1,000 gallons divided by 45. So equals pounds of N times 1,000 divided by this cell right here, which the computer's not helping me here. The computer does not want to help me. So I gotta make this cell bigger. Let's try it again. So again, equals pounds of N required times 1,000 gallons divided by pounds of N per 1,000 gallons. There's my gallons of manure I need. Just like I did by hand. You're just making the computer do what you did by hand. So I had the computer figure that out for me. I like to always make that a yellow because the computer, any cell when I'm teaching this, I want the cell to be in yellow what I had the computer do. Manure produced by this building is 1,100,000 gallons. How many acres can I cover, or acres fertilized with this building? Remember what I did here? I took gallons produced divided by gallons per acre to equal 250 acres. So gallons produced divided by gallons per acre. The answer is 250 acres. So what's nice about a spreadsheet is that I can come in here and I can literally change any of this data. If I decide I want to fertilize at the amount of 1.2 pounds of N per bushel, I just change that number and my other numbers are computed instantaneously. If I want to fertilize for a 200 bushel corn crop, I just change my bushels produced. I can have my spreadsheet round for me too. So anyway, real simple spreadsheet there. Computing bushels, or excuse me, computing pounds of N required, compute gallons of manure per acre required, compute acres covered. We'll go ahead and do a spreadsheet for number 4 right now. We'll just begin a new sheet here. Number 4 is much easier to compute by spreadsheet than by hand. If you look at number 4, here's a problem where we have a feed ration and we're trying to figure out what's the cost of this feed ration. We have 28 pounds of alfalfa hay, 17.85 pounds of corn grain, 3.15 pounds of oats, 5 pounds of soybean meal, 0.5 pounds of dicalcium phosphate, 0.3 pounds of salt, vitamins, trace minerals. Here are our prices. What makes this a little bit more of a challenging problem is that our prices are all in different units. Our hay and bean meal are in prices per ton. Our corn grain and oats are in prices per bushel. But a bushel of oats weighs a different number of pounds than a bushel of corn. The calcium phosphate and salt and minerals are in dollars per pound. So you can see what I've done here by hand is I've taken my price per unit, turned that into price per pound by dividing pounds per unit, and then multiplying that by pounds of ration to get cost per ingredient. And then I can add up my cost per ingredients to get total cost of the feed ration, and then divide that by pounds of feed ration. Much, much, much easier to do in a spreadsheet. So here's what I write what I know. My feeds: alfalfa hay, corn grain, oats, soybean meal, dicalcium, phosphate, salt, vitamins, trace minerals. Now when I make a column like this and it overflows into the next column, I'm just going to come up here, double click on this column, it makes it bigger. I'm going to underline by the way, my headings. What do I know? I know pounds fed per day. I know that, so I'm going to put that in there. 28 pounds of hay, 1785 of corn grain, 3.15 of oats, 5 of bean meal, zero point 0.5 of dicalcium phosphate, 0.3 of salt, vitamins, trace minerals. Now, I also know my price per unit. I have a $150 ton hay here. I have $4.50 corn. I have $2.50 per bushel oats. I have $300 a ton bean meal, 45 cents a pound dicalcium phosphate, and 25 cents of mineral pack. From there, all I need is pounds per unit, because I'm going to turn my cost per unit into cost per pound. I'm going to make that dollars, by the way. Hay is in tons, that's 2,000 pounds. A bushel of corn weighs 56 pounds. A bushel of oats weighs 32 pounds. A ton of bean meal is 2,000 pounds. And dicalcium phosphate in mineral pack is already in price per pound. So now I need to have the computer figure out price per pound. To get price per pound, I take my price per unit. It's $150 for 2,000 pounds. What's that cost me? 8 cents a pound. I can just drag that formula down because it's going to take the price per unit divided by pounds in a unit. And now we have all of our prices in price per pound. Now, take so I had this computed. Now I want to find cost per ingredient. So I want to find my total cost per hay, corn, grain, etc. The cost per ingredient is going to be the cost per pound times number of pounds fed. $2.10 of corn. I can go ahead and drag that formula down because it's going to take the price per pound times pounds fed for each and every row here when I drag that formula down. And now I'm going to add up the cost. So you understand, I have the cost of each of the 6 ingredients. Now I'm just going to simply add all of the ingredients. Again, let me redo that again so you can see that. I highlight the cells I want to add, go one more cell, come up here to auto sum, click it. Now I have my total cost. I'm going to label that. I need to know my total pounds so that I can get my cost per pound, so I auto sum again. So now to get my cost per pound, I come up here, take total cost divided by total pounds. There's my answer. My cost per pound is 9 cents. Hope this makes sense to you. Pretty simple spreadsheet. Really saves me a lot of time. If I want to change anything, if I want to change this feed ration, I can change the numbers here. And obviously you can see what happens to my total cost, my cost per pound, etc. So anyway, hope this makes sense. Hope you enjoyed it. Go ahead and design your own, and wish you the best of luck.